This conference will now be recorded.
Okay, right. So yesterday we were talking about the non-functional requirements and how to document the non-functional requirements, and also we were discussing about the activity diagram yesterday. So how does the activity diagram look like, and where exactly we use it? Then today we are going to talk about the remaining part of the UML diagram. So the first day when we talked about UML, we talked about the use case diagram where we have the actors and actors would be interacting with the system for different purposes. For example, in your project manager case, they would be using the system for creating the proposal or selecting or rejecting a candidate and so on. That's how different user group would be using the system for different purposes. And HR so would be using the system for posting the job internally, for posting the job externally, and so on. So this is similar to this is the use case diagram if we have to put it down for a recruitment system. For a recruitment system. So when we talk about the activity diagram, so the activity diagram is majorly talks about the activities or the functions functions that are performed to achieve the objective. It is similar to a flowchart. It's not very different. It is similar to a flowchart. But there are few additional symbols like fork and the join, fork and the join. So which are used to basically fork and the join is used to represent the parallel flows, which is the additional symbol that we see in the activity diagram. So though the notations are slightly different from flowchart, ideally it is very close to the flowchart if you look at the activity diagram. Then we talk about the next one that is going to be the class diagram. So class diagram and sequence diagram are majorly for the development teams. So what is a class diagram and what is a sequence diagram? And as a BA, so if we have the understanding of these two diagrams, that should be enough. So now if we look at the class diagram, how does it looks like? How does a class diagram would look like? And then what exactly are the different symbols that we see in the class diagram? And sorry, what I call artly are the entries, so that we'll have a look at it. Now when we talk about class diagram, it is more for the development team. So when they define the classes and objects in the object-oriented programming world. In the object-oriented programming world, when they define the classes and objects, so in order to develop the system, these class diagrams are useful for establishing the relationship and also defining the attributes and also defining the function. Now, if you talk about this particular example or this particular diagram, so you have the customer on one side, order on the other side. What does this customer is responsible for? So, sorry, customer has the attributes like so. What is meant by a class? A class is nothing but a collection of similar objects. Collection of similar objects. So that we call it as a class. So now under customers, you have the retail customer, wholesale customer, maybe a different type of customer as well. All customers would come under a customer class. So collection of similar classes. For example, just to give you a quick example. Vehicle is a class. Under vehicle class, you can have a two-wheeler, you can have four-wheeler, you can have a heavy motor vehicle, light motor vehicle, something. All these things are comes under vehicle class. In a similar sense, so we have customer is a class. So if you look at here, so the class have the attributes like customer name and the location. Customer name and the location. So that means that for customer class, we will capture the attributes like customer name and the customer location. And customer has So on the other side, you have the order class. The other side, we have the order class. So which has the details like order date and order number. Which has the details like order date and order number. So that means that the orders placed by the customers, you have the date for that particular order, you have a number that is defined or a alphanumeric value that is defined. So that way you have an order date and you have the order number. And the order class has two child classes which are called as the special order and the normal order. Special order and the normal order. So when you talk about the special order and normal order, so these are the child classes for this parent class. These are the child classes for the parent class, that is order class, special order and normal order. So we can also call them as the subclasses. Now, if we talk about other aspect that we need to look at here is the functions or the methods that we define in the parentheses. So what does customer be able to do? Customer can send the order, customer can receive the order. Customer can send the order and customer can receive the order. Customer can place the order, customer can receive the order. So these are the functions or the methods. So when we invoke a function or a method, it will trigger a set of sequence of things. So similarly, order class has some functions like confirmation of the order and closure of the order. So if you look at here, you have the special order and normal order, which are the child classes, which are also similar to the order class. In addition, you have something like in addition we have something like dispatch and receive. These are the additional functions for these child classes. So these child classes are derived from the parent class, this one, order class. This is a parent class. These are the child classes. So these are derived from the parent class. That derived from the parent class. So that way, when we talk about customer and the orders, these are the two different classes. And obviously, customer is the one who placed the orders. And for the customer class, you need to know customer name, location, and all the things. And for the order, you need to know order date and order number. And you have the functions like placing of the order and receival of the order, confirmation of the order, and closure of the order. And if you look at here, there is one more thing that we need to look at is the relationship. Each customer can place how many orders? N number of orders. Each customer can place n number of orders. But each order is corresponding to how many customers? Each order is corresponding to only one customer. So now the relationship is between the customer class and the order class is 1:n relationship. 1:n relationship. So that's what is different here. We are defining the attributes, we are defining the functions for each class, and also the relationship between the classes that are defined in a particular, like the use case or the requirement. Is that clear? Is it clear so far?
So why exactly, what happens or how do we utilize these class diagrams?
No, these are basically for the development teams to define the classes and the functions
Okay.
and the relationship between the classes. So when they are doing the development activity based upon the requirements. Okay.
Okay. That
Right.
makes sense.
So the class diagram provides an overview of the target system by describing the objects and classes inside the system and the relationship between them. So the class diagram shows the collection of object classes, their attributes and operations, and the relationship among the objects. So the class diagram shows the collection of classes and their attributes, whatever that we define, the customer name and the customer location, order date and the order number, operations or methods or functions one and the same, which are defined in the parentheses. And also you have something like 1:1 relationship, 1:n relationship, n:1 relationship, all that are defined under the class diagram. All that are defined under the class diagram. So when we talk about the best practices for drawing the class diagram, the name of the class diagram should be meaningful to describe the aspect of the system. The name that we define customer orders, like maybe the sales or whatever. So the name should be sensible to describe some aspect of the system. Each element and their relationship should be identified in advance. Whether it is one-to-one, one-to-many, or many-to-one, that relationship should be identified in advance. Responsibility, attributes for and methods of each class should be clearly identified. Responsibility and the functions of each class should be clearly identified. Attributes and methods of each class should be clearly identified while drawing the class diagram. Now, the example that we have looked at, a simple explanation around that example. So the following diagram is an example of an order system of an application. It's an order system of an application. So it describes a particular aspect of the entire application. A particular aspect of the entire application. First of all, orders and customers are identified as two elements of the system, and they have one-to-many relationship because a customer can have multiple orders. The relationship between the customer and the order is 1:n or 1:n relationship. We keep order class as an abstract class, and it has two concrete classes like special order and normal order. Special order and normal order. Just a moment, please. So now the following diagram is an example of order system of an application. So it describes a particular aspect of the entire application. A particular aspect of the entire application. So first of all, order and customer are identified as two elements of the system. They are identified as two elements of the system, and they have one-to-many relationship because the customer can have multiple orders. And we would keep order class as an abstract class, and it has two concrete classes, like which is called as the special order and the normal order. We have two concrete classes like special order and the normal order. So we would keep the order class as a parent class, and it has two concrete classes like special order and normal order. In the programming world, especially like when we talk about the OOPS concept, object-oriented programming concept, there is something called as inheritance relationship, where the child classes inherits the behavior of the parent class. So in this case, the child classes are the special order and the normal order. Special order and the normal order, which are the child classes. The two inherited classes have all the properties of the order class. In addition, they have additional functions like dispatch and receive. They have the additional functions like so. These two child classes inherits the same behavior of the parent class. In addition, a special order will have dispatch and receive. A normal order will have the dispatch. So it may be a gift order, something of that sort. So which have the dispatch and receive or immediate order. So while the normal order will have only the dispatch, something like that. So that way, so if you look at the order system of an application, an online order system of an application, when we are talking about the relationship between the customer and the orders and what customer is responsible for, so that is defined under the functions, and customer has certain attributes, while similarly you have the order on the other side, so which has the attributes and which has the functions. The order class has the functions. So that way, when we talk about the class diagram, it describes a particular aspect of the entire application and the relationship between the classes and basically the functions that are performed by each of the classes. Is that clear?
Yeah.
So now this is the example that we were talking about. So then customer class has the like a relationship with the order class. It's one is to n relationship. You have the parent class and you have the inheritance relationship. By using the diagram, if you have to define the inheritance relationship, this is how we define the inheritance relationship. So this symbol is to define the inheritance the relationship, where the child classes inherits the behavior of the parent class. Now, so the purpose of having the class diagram, it describes the static view of the system. It doesn't change for a period of time. Now, if you talk about the activity diagram, so what happens is with the time, the workflow will move from one stage to the other stage. While here, so the class diagram defines the relationship between the static elements, so the classes, and it is going to remain the same, showing the collaboration among the elements of the static view, showing the collaboration among the elements of the static view. So this describing the functionalities performed by the proposed system, the functions in construction of software applications using object-oriented programming languages. So for those systems which use object-oriented programming languages, OOPS concept, so the class diagrams are quite sensible. The class diagrams are quite sensible. Okay, any questions before we move on? Divya, Kanu?
No.
I'm just trying to understand how are we, I mean, I can understand about the UML and things like that. The activity diagram, I'm not sure, I mean, what part is BA playing in that?
Activity diagrams, we need to define, we should be able to define the activity diagrams as stated. If not activity diagram, it's not necessary that you need to be creating only the activity diagram. It's not
Okay.
that way. So if you can create a flow chart, which
Uh-huh.
makes far more simpler understanding, That's right. So the activity
so it's
diagram, you have only these parallel flows that you can define, which
right.
cannot be possible otherwise. Okay, it's basically any
Oh.
diagram that we use. There is no mandate that for writing the document you need to go about and creating the diagrams and stuff. So, but if you feel that it makes sensible for everyone, or it is easy for everyone to understand the diagram, so that's when you can definitely create the diagrams.
So I think it's
Okay.
just either of these things that you can
Yeah, anything should
utilize to explain the concept, or the
the
activity that's taking
workflow
place.
are
Right.
the processes that are
Right.
existing in the system. So that should be enough.
Oh, okay. That makes sense. Thank you. Yeah.
Right. So moving on to the sequence diagram. So this is also similar to the class diagram, more useful for the development team. So I'll tell you what would be the purpose of it. Now here, if you talk about this particular example, which is related to online shopping cart, online shopping portal. So here we are defining 4 different Process are the objects. We're calling them as the object: customer object, product object, stock object, and the payment object. What does customer object will do? So now if you see here, so this particular one is the ideal state of the things. Ideal state, nothing doing. I mean, customer object is idle. Product object is idle in this point of time. The ideal state is defined by dotted line. Then we have the activation part that is defined here. The activation part that is defined here with the rectangle. Activation part is defined in the rectangle. So now when we talk about the customer objects, so the moment you do www.amazon.com or any online portal, so the activation part is shown in this rectangle. The activation part is shown in this rectangle. Now, what does customer will do once the the product is the application is launched? Customer object will search for a product. They will enter a keyword and click on search. So what will happen? It will send a request. So request to what? So now I am searching for a washing machine. So the moment I click on search, so what it will do? It will send to a different process. So that we call it as a product object, which is running in the background. Now if you see here, the major important thing that we need to look at it, customer object is active at this point of time. But that point of time, the product object is still idle, not doing anything. So when the product object has become active, when there is an incoming request, the product object has become active. That means that only when there is a request to invoke a particular process, only then the product object is active. The product object has all the product related information, product specifications and dimensions, and then all the errand details, all the in and around details. But product object does not have the availability or the stock details, so which are there in a different object, which is called as stock object, which is there in the different object, which is called as stock object. So the product object has to get the information of the product details as well as stock details. What it does, it sends a request to the stock object, whether the product is available or not and all that. So if the product details are available, yes, there will be a response, and sorry, the stock details are there, and then product details. So that will be showcased on the screen, the customer screen. So once the response is received, you can see the product, the list of washing machines, and with a specific image, and then you have a buy now option something, and simple description, maybe a 2-3 liner description of each of the products. Each of the products. So like this, you'll see the list of products and simple description about it. So if you want to make the payment, so once you want to make the payment, what it does, so the payment object is idle till when? until it gets a request to make the payment. So once we get a request, so the payment object will become active, and it facilitates the payment mechanism, and it will generate the receipt. It will generate the receipt. It will be showing up on the screen. So that means that in the sequence diagram, the name itself says that the sequence in which the messages are flowing, that's very important. Only when there is an incoming request, the process is becoming active. Until we get the incoming request, the process is idle, not doing anything. So now if you look at the sequence diagram, it models the collaboration of objects based on a time sequence. It shows how the objects interact with others in a particular scenario of a use case. So a popular use for them is to document the dynamics in object-oriented system. For each key collaboration, for each key interaction, the diagrams are created that shows how objects interact in various representative scenarios for that collaboration. So that way, when we talk about the sequence diagram, it shows the collaboration of objects in a particular scenario of a use case. So the scenario here is to buy the product online. So in order to buy the product online, if you have to create a sequence of messages and a sequence diagram, so the one that we have looked at, so that's basically an example of the same. So the following things are to be identified clearly before drawing the sequence diagram. So objects taking part in the interaction, the message flows among the objects, how the messages are flowing among the objects, the sequence in which the messages are flowing, the sequence in which the messages are flowing, the sequence in which the messages are flowing in the system. So when we talk about the sequence diagram, the following things are to be clearly identified: objects taking part in the interaction, the message flow, how the messages are flowing among the objects, the sequence in which the messages are flowing. So these are the important things that we need to understand. Now, when we talk about the example of a sequence diagram, it is having four main objects: customer, product, stock, and the payment. Customer object requests for certain product. Product object then check the availability of the product from the stock object. Once the response of the availability is received by the customer object, then customer object will then make the payment. Payment object sends back the receipt message to the customer object. Payment object sends back the receipt message to the customer object about the response. So that's the sequence that is defined in the sequence diagram. So this is the sequence diagram. These are the different objects taking part in the interaction. So the purpose of sequence diagram, the main purpose of sequence diagram is used to capture the dynamic behavior of a system. It is used to capture the order of messages flowing from one object to another. The order of messages flowing from one object to another. It is used when we want to understand the message flow. Now the message flow means sequence of control flowing from one object to another. The sequence of control flowing from one object to other. So how the controls are being moved from one object to other, that is defined in the sequence diagram. Is that clear? Any questions?
No.
So that's about the sequence diagram. So why we need to use the sequence diagram? So what is the purpose of we using the sequence diagram? So when we talk about the sequence diagram, so when we especially develop the software system, so we keep in mind the non-functional requirements also, like the performance of the system and so on. So for example, if you talk about this example, and the moment if the customer object is active, if all the other objects started active, that means running in the background, though it is not required, what will happen? It will utilize the CPU capacity, the system capacities, or the server capacities. What will happen? The system will slow down drastically. So that's where the sequence diagram is useful to control that with the message flow. So whenever there is an incoming request, then only invoke this process. Until then, the process needs to be in ideal state. Until then, the process needs to be in ideal state. That is the whole intention. So that is where we improve the performance of the system drastically, making sure in the sequence the object should be active. Is that clear? And one other important point that I need to tell you is, so the last statement says that the sequence diagrams are used when we want to understand the message flow. It is just not message flow. It shows the sequence of control flow flowing from one object to another. Control of what? So when you talk about customer object, so when they do www.amazon.com, the control is on the UI screen. That means you have to do something, then only internal processes will start. The control is on the UI screen. The moment you search for a product, so it will be like it will be the process will start. It will send a request to the background object. So, and in between, if you try to do something else on the UI screen, the system will get stuck. The screen will get stuck. You can't do anything during that time. Until when? Until you get a response. So once you get the response, again you can do something here on the screen. That means that the control is being moved from one object to other. That can be shown by using a sequence diagram. So until that control is passed to the another process, that process cannot become active. Is that clear? Divya, Kanu, is it clear so far?
Can you also give some
Yes.
other example for the control, like you explained
the
for the
control-
Amazon?
You can see that examples online. So there are many the images and all this and like, so that way you can easily understand the objects defined in a particular use case and then the relationship. Sorry, not the relationship, the sequence of messages. Okay, if you still have any question, you can talk about the examples. Okay.
Okay.
All right. So for drawing the UML diagram, you have the Visio, the Microsoft Visio, which can be used for creating the UML diagrams. Or Rational Requisite Pro, there is another tool, but that is a costly tool which is used by IBM, so which is of IBM's tool, so that's not very much required. So the major one is the UML diagrams. Sorry, the Microsoft Visio, which can be used for creating the UML diagrams. Okay. All right. So with this, I'm stopping here for today. So I have some emergency to. So we'll talk about the SQL part tomorrow. So the querying part and how to write all the queries and stuff. So that we'll discuss in the next session. Okay. Any questions before we wind up the session for today?
No.
All right. Thank you so much and see you tomorrow.
Thank you, Karan.
Yeah.
Thank you. Bye.
Thank you.